Okay, I know I'm nerdy, but I think this is so much fun. I just absolutely love it. With this one, we have a proportion again, x is to y as 5 is to 6. And I want to complete each statement based off of this proportion. Remember, x and 6 are my extremes, and y and 5 are my means. This is the first thing they tell you. 6 times x is equal to what? 5 times y. Now, I'm going to ask you this one, why? Okay? And the reason why is that's the cross products. They're equal to each other, and I can do that. So the cross product is true. Now look at the next one. Y is to x as, now I'm going y is to x. So what am I going to be doing here? That's right, inverting it. So I get y is to x as 6 is to 5, because I want my cross products to still be true. So that's invert the proportion. So invert, my v never works right anymore. So invert the proportion. Then I get the following, x is to 5. Well, how did I get x over 5? What would I have to do? I want to move the 5 where? Down here, which means the y would have to go where? Over the top. So x is to 5 as y is to 6. Now, what two things switched? Those are the means. That's right. So that's switch the means. And the last one is x plus y is to y as, I'm going to say it's 11 is to 6. Now, what did I do? I just took and went 5 plus 6 is to 6. That's just add the denominator. Excellent, excellent, excellent. Those aren't hard, but think of it as kind of a puzzle. How do I change this one? And the cool thing is you can do multiple ones of these. You can do 3 or 4. You could invert and then switch the means, or invert and then add the denominator, or add the denominator and then invert. It would still work. So, no, you can do multiple ones of these. All right, now we're going to do some other examples that are very simple. I'm just doing a ratio. It says, for a rectangle, find the ratio of the longer side to the shorter side. It's just learning how to communicate that. So I want longer to shorter. And so we're just going to go 70 to 25. And what does that reduce down to? 14 over 5. The other way you could do it is 14 is to 5. Now, I'll tell you right now, don't do that. You want to get in the habit of just keeping it as a fraction. The next one, in a scale drawing, the scale, okay, this is so funny. In a scale drawing, the scale is a ratio that compares length in drawing to the actual length. Now, this again is one of those things for blueprints. And again, it doesn't matter, I think, until you build your own house or you try to build a model or something like that. You want the scale. It says the following: apartment building is 90 feet tall and 55 feet wide. The scale model of the building is 11 inches wide. How tall is the scale model of the building? So I want to do a correspondence with this, okay? So I'm going to go the scale model to actual. So I want to do the actual, okay? So that means model, and I'm going to rewrite it like this now. Model to actual is what's my scale, okay? Model is 11 inches wide. If I'm talking about wide, I have to go wide here. So 11 inches to 55 feet. Now here's the cool thing. If I'm doing this to scale, I don't have to change the inches or feet. I'm just going to literally go 1 inch is to 5 feet. Okay, so 1 inch on my scale is 5 feet in the real thing. So when I want to know how tall the scale of model of the building is, I go 1 inch is to 5 feet is the same thing as, oh wait, how tall is the building? 90 feet. And it's the actual, right? So I go 90 here as what? X. Now, seriously, you can ignore the labels for right now. We just need to know where they go in the long run. And remember, this is going to end up being in inches. So cross multiply. 5 times x equals 90 times 1. Divide by 5. X is going to equal 18. The model is what? 18 inches tall. Alright guys, that's basically what we're going to do with proportions. Now in honors, you're going to do some factoring. So if you don't remember how to factor, you're going to have to come talk to your teacher, okay? Guys, go have a great evening.